Okay, problems 29, 30, and 31 start at the bottom of page 826, dealing with types of cereal. We know that Mrs. Alexander is going to purchase 3 boxes of cereal at a convenience store. The store has 12 different boxes of cereal, including 5 different boxes made by General Mills, 4 made by Kellogg's, and 3 made by Post. If Mrs. Alexander selects 3 of these 12 boxes at random, determine the probability that she selects, in problem 29, 3 boxes of General Mills, in problem 30, no boxes of Kellogg's, and in problem 31, at least 1 box of Kellogg's. Now, it doesn't specifically say in this problem, but I'm going to assume that she selects these boxes without replacement. So, as if she were going to go buy them. So she just picks one kind off the shelf and puts it in her grocery cart, and then she's not going to pick that one again. Or she's not going to put it back on the shelf. It's in her grocery cart, she selected it. So the first time she grabs a box of cereal, there are 12 to choose from. There's 12 kinds on the shelf. If we're wanting her to get General Mills, how many of the original are General Mills? We know there's 5. So if she just at random grabs a box of cereal, there's a 5 out of 12 chance that she will pull down a General Mills box of cereal. But what about the second and the third boxes? Well, this problem is an AND problem in disguise. Another way to phrase the question, what's the probability that she selects 3 boxes of General Mills? Another way to phrase that is to say, what's the probability that she selects a General Mills cereal, followed by another General Mills cereal, and followed by a third General Mills cereal? Which means this is an AND problem and involves multiplication. So for the first box, there's a 5 out of 12 chance. For the second box, if we assume she can't select a variety she's already selected, there are now 11 to choose from, and how many of those are General Mills varieties? Well, 4, because she has decreased the number of choices by 1, having already selected a General Mills cereal with her first choice. And then lastly, for the third box, there are now 10 choices, and 3 of those would be still General Mills. So we plug that into the calculator and reduce our fraction, and we end up with 1 over 22. And this is multiplication. Multiply these 3 fractions together and reduce, you get 1 over 22. Problem 30 says, what's the probability she selects no boxes of Kellogg's? Okay, this means not Kellogg's on the first one, and not Kellogg's on the second, and not Kellogg's on the third. So it's an AND problem, multiplication. There are 12 boxes of cereal. At the start, how many of them are not Kellogg's? And the answer is 8. Since there are 4 Kellogg's boxes, the other 8 must not be Kellogg's. Then for her second box, there's 11 left to choose from. 7 of them are not Kellogg's, and then 10 left, where 6 are not Kellogg's. Multiply those all together and reduce, and we get 14 over 55 is the probability that she selects no boxes of Kellogg's cereal. And then problem 31, what's the probability she selects at least 1 box of Kellogg's? Now this has a special formula because calculating the probability of at least 1 is very difficult without thinking of it in this special way. The probability of at least 1 is always 1 minus the probability of none. So in our case, it's no Kellogg's. So probability of at least 1 Kellogg's cereal is 1 minus the probability of no Kellogg's cereal. And what do you know? We just calculated the probability of no Kellogg's cereal is 14 out of 55. So the probability of at least 1 is 1 minus 14 out of 55, which is 41 out of 55. Okay, problems 59 through 62 are found at the bottom of page 828. Told that a bag contains 5 red chips, 3 white chips, and 2 blue chips. Let me just write that down up here. 5 red, 3 white, and 2 blue chips inside this bag. 3 chips are to be selected at random without replacement, meaning we don't put them back in the bag after we pick them. Determine the probability that problem 59 says all are red. So that means we draw a red and another red and another red. This is an and problem, so we're going to multiply. So for the first chip, what's the probability you draw a red one? Well, there are 10 total chips, so that's our denominator. 5 of those are red. For the second chip, since we didn't put it back in, there are now 9 chips remaining in the bag, 4 of which are red. And then for the third chip, there would be 8 remaining, 3 of which would be red. Multiply all those together and reduce 1 over 12. Problem 60 says, what's the probability that the first 2 are red and the third is blue? Well, there's still 5 out of 10 for the first, 4 out of 9 for the second. Now there's 8 chips remaining at this point in the bag. How many of those are blue? Well, we haven't taken a blue one out yet, so there's 2 that are blue. Multiply those all together and reduce, and we get 1/18. Problem 61 asks for first being red, the second one white, and the third one blue. So the first one red is 5 out of 10. There's now 9 in the bag. How many of those are white? 3. Now there's 8 in the bag. How many are blue? 2. Multiply and reduce. We get 1 over 24. Which brings us to the last question right here. What's the probability that at least one is red? Well, the probability of at least one anything, remember, is 1 minus the probability of none. So in this case, probability of at least one red is 1 minus the probability of no reds. Well, we haven't calculated the probability of no reds yet, but we can easily do that. So I'm going to scroll down a little here. Probability of no red would be, well, there are 10 original chips in the bag. How many of them are not red? Well, if 5 are red, these 3 and this 2 are not red, so there's 5 that aren't red. And then there's only going to be 4 out of the 9, and lastly 3 out of the 8 that aren't red. In fact, this multiplication is the exact same multiplication as up here in 59. 5/10, 4/9, 3/8, 1/12. So back to the problem in 62, if I want the probability of at least one red, that's 1 minus the probability of no reds. So 1 minus what we just calculated, 1/12, which is 11/12, the answer to the problem.